This is a photo editor. I've uploaded an image here. Now we'll start clicking here. So this matrix here gives us the values of RGB for each coordinate and the neighbors. So when I click on this blank space, it should give 255 for RGB everywhere. If I click something in between on the edge, say I'll click something on the edge, then it shows. So this is the zoomed image here. Now the right side is white, so all these pixels should be 255. So they are approximately 255, 54, 50, in that range because they are very bright. And on this side you have RGB colors of these pixels here. Now the transformed one, so we have two images, one is the original, one is a transformed one. So let's try to invert the colors. So if we invert the colors, what happens is in inversion, red goes to 255 minus red, green goes to oh, green goes to 255 minus green, blue goes to. So these pixels, the ones which were here, all these 255s, they should all be near zero. So they are all approximately zero. This is not clean white, and that is probably because of JPEG compression. But had it been BMP, probably all these pixels would be pure white. But you can see here there is some shade which is non-white. But no problem. We'll invert it again and we'll get back the original image. Now, if we increase the brightness, so I don't know, probably I have not, uh, this should have changed, but I think that that function I have made wrong. No problem. We'll look at the other functions here. So, but it increases the brightness here, right? So, increasing brightness, what it should do ideally, even though I have not done here, these pixels should get more and more towards 255. If I reduce brightness, these should all go towards zeros. Now look at the threshold. What threshold does is if brightness is above 128, then it will make it white. If it is below 128, it will make it black. Let's apply trans threshold. So what threshold does is if it is greater than threshold, if the pixel value, which value, the brightness value, is greater than the threshold, then it will give us black, pure black. So this is just two colors, black and white, and not even the shades of gray. There are no grays here. So if we keep the threshold low, I'll have to reset the image. If we keep the threshold low and if I change it, then look at what happens. And look at this transformed image. Here you will get only either zeros or ones. Let's go to some neighborhood where you will see it better. Yeah. So all pixels are either 0 or the complete 255, either pure white or pure black, nothing in between. So, okay, now let's look at channel splitting. So what we'll do is, if this is the color, if I split the channel, if I keep red, what happens is green and blue components become 0. Again, we'll reset, and if we take only the green channel, what will happen in this pixel? Only the RGB, only the green color will be taken, the rest will become 0. So that is how we take the three channels, RGB channel. So that is here, but that explanation is also coming here. The new pixel will be old pixel red, and green and blue will become 0. So okay, now let's reset this image and let's take a blur. So if we smooth, what happens is we take the average. So this was the kernel that we had talked about. Here we'll take the average of the neighboring 9 coordinates. So so what happens is you take x coordinate, you multiply each coordinate. So let's take one coordinate and we'll see. So let's zoom in here. Let's see this coordinate. So what the transformed coordinate will be, it will be the average of all these colors. So what we can also do is take something which is more towards white. So it will easy, yeah, let's take here. So look at this coordinate 255, everything around this 255, here 255, 55, 55, 55. So all these, we are looking at this guy. Now here, except this, everything is 255 and this is 10 less. So I think the average should be 254. Look at this, 254. So what is happening is we are taking the average of all these nine guys. Here, if you look at this, the transformed pixel here will be the average of these nine guys. So look what happened is slightly this gets blurred because now it is getting averaged out. You can blur it again. If you blur it again, keep blurring it. What happens is that image gets blurred again and again and again. If we sharpen, I don't know the sharpen how sharpen function is written, but I should look at it. So here is the sharpen function. So we can create our own sharpen functions. It is not necessary to use this one, right? We can use our own. So blur function that was used was direct average. You could have given higher weightage to the middle coordinate. You could have given it a weightage of 2. So that could also work. Now let's reset this image and go back to left edge. So left edge, what we were doing, you remember, we were moving from the left to the right. So what we are doing is x and y, x minus 1. So the x coordinate this and this, we are taking the difference. Let's see how the pixel works. So let's look at, uh, so if you look at these two pixels, so I'll have to look at the maths. But the broad idea is this. What we do is we look at the difference of, so what we have done is we have taken the average and then we have taken the average color, means you take r plus g plus b by 3, and then the transformation is you take the you subtract the x coordinate, keep the y coordinate same. That is how we do the left edge detection. If we have to do the top edge deduction, then what we will do is we will use the y coordinate difference. See, x will remain same. Okay, here uh, the text I have not written, but what will happen is we will take the y difference, y2 minus y1. So y coordinate. So there are there are many more ways to find the edges. Some are like so you can take other methods also. You can think of your own methods to find, but we'll talk about it. But the broad idea is we have to take the difference. Mm, okay, so what else is there? Downscale. This is simple. We have to reduce the size by half or 45%. So downsizing also there are many ways to do it. One way is to take the average of the nearby pixels and compress. The other way is to, if we were to downsize by 50%, what we can do is just take the alternative pixels. First pixel, third pixel, first pixel, third pixel, fifth pixel, seventh pixel. Then you will be downsized by 50%. The other way is to take the average of 2 pixels and put in the first. So there are many ways to downscale also. There is no defined particular one way to downscale. Now rotation is simple. We'll simply rotate. So this is the rotation. So rotation, this is simple coordinate geometry, x minus x cos theta. This is simple complex, yeah, coordinate geometry. We can do it by transformation also, vector transformations, matrices. Okay, that is okay. So we'll reset the image. Now, what else have I done? Yeah, flipping horizontal. Horizontal flipping is simple. X coordinate will go to the total number of pixels minus x coordinate. The intensities of RGB will go there. So this is a very simple image editing tool. We can create more complex ones, but for now, this is all we have.